Initial environmental examination. Sewerage project, Bagong Lipunan Condominium and Tenement. Project description. Name of project: Sewerage project, Bagong Lipunan Condominium and Tenement. Address: Bagong Lipunan Condominium and Tenement, Barangay Western Bikutan, Taguig, Metro Manila. The proposed project for Bagong Lipunan Condominium and Tenement, or BLC, is one of the 23 sub-projects of the Community Sanitation Project Phase 1, which is a component of the World Bank-assisted Manila Second Sewerage Project, or MSSP. The project is intended to reduce the current wastewater pollution discharge to the Laguna Lake by the 1,213 residential units in BLC. The project involves the improvement and rehabilitation of the sewerage system in the compound. Specifically, the project includes the installation of sewer lines to intercept sewage flows from existing communal septic tanks, as well as raw wastewater flows from buildings without septic tanks. An underground centralized sewage treatment plant, or STP, will be constructed to treat the wastewater flows. This is the vicinity map of Bagong Lipunan Condominium and Tenement in Taguig. Scope. This project specifically aims to address the problems of inadequate wastewater treatment and disposal in BLC. The project will help reduce public health risks and environmental pollution from untreated or partially treated domestic wastewater by providing a sustainable sanitation and sewerage facility. It will also serve as a good illustration of proper sanitation, especially to the neighboring communities near Laguna Lake. These are the parameters that will be considered: pH, suspended solids, dissolved oxygen, biochemical oxygen demand, chemical oxygen demand, total coliform count, and fecal coliform count. Environmental monitoring plan. Parameters under construction phase. Compliance with Manila Water Company health and safety policies includes dust emissions, good housekeeping, noise, and others. Location: STP site and its perimeter. Pipe laying area, equipment and material storage area. Frequency: on-the-spot daily inspection and monitoring will be implemented by the Health and Safety Department of Manila Water Company using the STARR card or Annex 1. The second parameter under construction phase is traffic. Location: ingress and egress to the construction site. Frequency: daily. These are the parameters under operational phase. Effluent water quality for parameters like pH, 5-day, BOD, COD, total coliform, suspended solids, oil, and grease. Location: influent, samples from treatment stage. Effluent. Frequency: Annex 2 describes in detail the schedule of wastewater quality monitoring. The second parameter under operational phase is odor. Location: STP site and perimeter. Frequency: daily. And the last one is large accumulation or clogging. Location: at STP site, sewer network, and communal septic tanks. Frequency: weekly. Impact and its mitigating measures. Poor quality construction. Manila Water Company will monitor the supply and installation contract to assure quality of equipment and construction. Site managers and engineers with experience in construction management shall approve all materials and equipment to be used and installed at the site. The contractor will be required to post a performance plan for the design and construction contract of the sewerage system. Air pollution. Efficient construction planning and work scheduling. Prompt and fast removal of excavated materials or dredges posed for construction site. Sprinkling of water on dust-generating modes resulting from earth-moving activities and civil works. Wastewater pollution. Provide temporary drain systems and storage facilities for excavation soils, fuels, oils needed for construction. Provision of routine chemical and oil spilling cleanup plan. Process. The project will be bid on the basis of performance specifications for the SDP treatment process. Wastewater flows were computed on the basis of a per capita water demand of 200 liters per day and a 70% wastewater discharge. Storm infiltration was estimated at 10% of the total flows. A peak factor of 1.5 was added in the computation of design flows to determine pipe sizes and capacity of SDP. Process scheme of SDP. The SDP to be constructed in PLC will be below ground. The only above ground structures will be the control room or panel. The SDP treatment process will provide secondary treatment to septic tank effluent. It is expected that the bidders will propose different process technologies based on the performance specifications in the bid documents. Some factors which will be considered in selecting the SDP treatment process are suitability in project site, performance or treatment efficiency, capital and replacement cost, operation and maintenance costs, complexity of operations, and flexibility of treatment process. This is the flow chart of the general treatment process scheme. It can go in two ways. The first is raw sewage, lip pump, surge tank, 2-degree treatment system biological, going to the clarifier, disinfection, chlorination, and lastly to clarified effluent. And the next is raw sewage, lip pump, surge tank, 2-degree treatment system biological, clarifier, down to the waste sludge, dewatering, filter press, and reuse sludge as soil conditioner. Thank you for watching.